I want to use this video to show you actually how the meter does some measurements. And I'm going to include a little tool I have here, and this can adjust the duty cycle as well as the frequency. If you're interested in this, I'm building these. Let me know and I'll see if I can get one to you and find out what it costs. I'm also going to use the small U-scope just for demonstration to show you the signals. So the first thing, let's go ahead and turn on the U-scope. Let's turn on the frequency and duty cycle generator, and then I'm going to go over to my voltage. Now it's a little bit difficult to read everything because I had to adjust the contrast so that we could see everything correctly. But right here I'm running at 2005 hertz, and let's just make that exactly 2000 hertz. There we go. And I'm currently at a 73% duty. Now, if you look over on the meter, we're running at 8.65 volts, which is not exactly true. And you can see my scope going across the screen really crazy. It's way up at the top up here. So I'm going to come over and I'm going to change these voltages so that we're going to get something like this. And you can see the maximum voltage here is around 13.9 volts. And I'm going to change the time so we can actually see the signals a little better. So let's slow this down. So now you can see the actual pulses that are taking place. Let's do that. And this is the amount of time it's at ground, and this is the amount of time that it's at positive voltage. And you notice that it's reading maximum voltage of 13.9 volts, but yet over here we're getting 8.65. I don't know if turning this light on will help a little bit, but we're getting 8.65 volts on this meter. So this meter is actually averaging this duty cycle. And if you notice, if I change my duty cycle and I give it more duty cycle, so I leave the on time more, and you'll notice that this got bigger and this got shorter, and my voltage went up over here because it's got more on time. If I change my duty cycle to something really small, let's go down to 15%, you'll notice that now the on time is considerably small and the off time is considerably large, and the voltage is averaging out at 1.5 volts. So this is how this is going to respond. It doesn't actually see the maximum voltage. I'm going to bring this duty cycle up a little bit. Let's do a 30% duty. We're over here at 3 volts. So you say, Tom, why can't we use maybe the min-max to capture that high voltage? So let's go ahead and put that min-max on. And what you're going to notice when I click on maximum, it still says 3.36 volts. And when I go to minimum, it says 3.36 volts. And of course, my average is 3.36 volts. Well, this is where your peak min-max can come in. This is a much faster rate. However, watch what happens when I go into peak. Now, it says my peak's voltage is 12.41 volts, and my minimum is 0, and my maximum is 12.41. And then it doesn't even have an average for that peak right there. So this is a way, if you want to grab a maximum voltage, you can do that. Otherwise, a meter that only refreshes about 4 times a second is going to average out that voltage based upon this duty cycle. You can also see what happens to the light over here, and the light will get brighter if I give it more duty. As the voltage goes up, now we're at 100% duty. We're reading at 12.29 volts. This here is at 12.4 volts. So that's all the time. But as soon as I start to go into a little bit of a duty cycle down here, we're going to be able to see this light start to decrease in intensity. So let's take that off of min-max and let's go back up to where we were at. So I think I was around 35%. There's my frequency, there's my voltage at 4.22 volts, and then I'm at 530 hertz. And now watch as I increase that. I'm going to take that up to 1,000 hertz. Okay, there's 1025. Voltage remains very close to the same voltage over here. If you were watching the oscilloscope down here, you'll see the patterns get more frequent. The light intensity didn't change. Let's take that up closer to 2000 hertz. Okay. Doesn't really matter, but that's 2040 hertz. And you can see again, the patterns got closer together. The voltage changed very, very minor over here. Very little voltage change, but we will not get an amperage change in that. So let's see how that's going to take effect if we go to amperage. So I've now taken my meter and I've taken my power supply, which is right here. I've connected it to the red lead on my meter. I've taken the ground lead and brought the power into the light bulb or my load. I've moved my red lead from the voltage terminal over to the milliamp range, the 400 milliamp range, the low range, and I've selected the milliamp DC over here. And now we can see that we're running about 77.6, 77.7 milliamps, and that's what's driving that. Now, if I move my duty cycle up, you will definitely see those amperage go up, but you will also see the light intensity change. So now we're at 155 milliamps. And you would also, if you were looking down here, you would see that the positive side of this has increased the time across here versus down here. But let's take this back down a little bit so it's a little more obvious on the light bulb. So let's take this down to something, let's go something relatively small. Less than 50%. There's 45%. So you see the intensity, we see that we're somewhere around, we're bouncing right around 97 milliamps. And we're at a frequency of 2.4 thousand hertz. You can see the frequency down here. Now let's go ahead and move this frequency down. So let's take this down considerably lower. There's 900 hertz right now. And you'll notice that the amperage, if it did change, it changed ever so slightly here from 97 to 100. This is what changes over here, is the frequency of time that things happen. Let's see what happens if I go down even more. So there's a very, very little amperage change. We're not going to get any light bulb intensity change going on. Let's take this up. And remember, we're measuring really small into the milliamps. Now, if I move this over to the larger amp scale, we may not see that. So now it's going to not be quite as sensitive. And we're at 102. And let's see what happens if I bring that frequency down. So we get a very slight amount of amperage change when I bring this down. And we're talking just a couple of milliamps, not nearly enough to change any intensity that's going on here. So the frequency really doesn't have any impact on the amperage that's going into a device. You can see it changing down here really well. But the intensity is not changing and the amperage is changing ever so slightly. Not enough to impact this over here. What impacts this is going to be your duty cycle. So let's go ahead and bring that duty cycle up. There's 100%. We're looking at almost 200 milliamps, or if I bring it way down, that's completely off. There is 5%. With 5%, you can't see this. It doesn't show on the camera, but that light has got the slightest amount of glow. If I change make it really dark, I don't know if I can do that, but let me just see if I can temporarily make this really dark, and so you can see that. So there's that light ever so slightly. Let's go up duty cycle to 10%. Now you start to see it barely come in as I go up to 15% and 20%. So you can barely see that light coming in there. In summary, changing the frequency has little or no effect on the amperage that flows through the electrical device, which does not change the work output of that electrical device. When the work output of an electrical device needs to be controlled, changing the duty cycle or the on-off percent is the preferred method to control that device. The Fluke digital multimeter averages the measured values based upon a sample rate of about 4 to 5 times a second. Using the minimum maximum feature increases that sample rate to around 100 milliseconds, and using the minimum maximum peak feature increases that sample rate to 250 microseconds.